All right, welcome back to the deep dive. So today we're looking at a project that technically fits in the palm of your hand, but wow, it represents a massive headache in robotics integration.
It really does.
We're talking about the HomeGenie Mini 1.2 ecosystem, and specifically this new FPV RC car.
It is such a deceptive little machine. I mean, you look at it and it seems like a standard 3D printed rover.
Yeah.
But the architecture underneath is surprisingly sophisticated. It's tackling what I call the triad of DIY robotics.
Yeah.
You've got motion, real-time video, and AI processing all at once.
And that's usually where these builds just fall apart. You try to cram too much onto one chip, and the second the video quality goes up, your motor control just dies.
Exactly. Latency is the enemy. And that's why the key insight here isn't the card itself. It's the dual controller architecture. HomeGenie figured out you just can't run a heavy video stream and high-speed servo loops on the same processor, not without major compromise.
So they split the brain.
They split the brain. You have a motion controller. It's an ESP32S30. It runs this smart motor firmware, and it does one thing and one thing only. Manages the servos.
All 8 of them.
All 8 if you have the arm. So 4 for the wheels, it's a 4WD skid steer, and then 4 for the robotic arm.
Which leaves all the heavy lifting for that second chip.
Right. The vision controller, that's a whole separate board, the ESP32S3 cam, and it's running its own smart cam firmware.
And its only job is video.
Just video. Capturing, encoding, streaming.
Yeah.
So because they're physically separate, a lag spike in the video will not cause your car to physically stutter or, veer off course.
That's smart. It decouples the eyes from the legs. But okay, running 2 microcontrollers plus 8 servos, that sounds like a recipe for a power disaster.
Oh, for sure.
I mean, when those servos torque up, they spike the current.
And you get a voltage drop, a brownout. And what happens is the sudden power draw, it starves the microcontroller and your whole robot just reboots.
The last thing you want mid-drive.
To fix that, the build uses the HomeGenie motor controller shield. It's basically hardware that acts as a buffer.
Like a shock absorber.
Exactly, a shock absorber for electricity. It has these large 1,000 microfarad capacitors that just smooth out the power delivery so the voltage stays stable even if you slam on the gas.
Speaking of driving it, I noticed they finally moved away from those, touchscreen controls.
Thank goodness. Yeah, the update adds USB and Bluetooth Gamepad support, so you can map the car to a physical controller.
So it feels more like a video game.
Much tighter. Way less like fighting with a UI.
Now let's talk about the mini part here. It's not just a car, it's a platform for this robotic arm V2.
This is the add-on that really turns it from a rover into a manipulator. And the V2 update is a pretty big deal because of the new mechanics.
The gripper, right?
Yeah, they redesigned the gripper to reduce gear friction.
That's huge for longevity. I mean, friction is heat, and heat just kills those tiny motors.
Precisely. But the coolest functional change is the camera placement. On the V2, the FPV camera mount is integrated right onto the arm itself.
Oh, so you're not looking over the hood anymore. You're looking from the hand's perspective.
Which makes grabbing something remotely actually possible. But there is a massive gotcha here in the assembly notes.
Oh, the pre-centering rule.
Yes. It is so critical. You have to connect the servos to the software and set them to 50% before you screw anything together.
Before you even start building.
Right, because if you assemble the plastic parts while the motors are at 0, the whole arm will be permanently misaligned. You'll just have to pare the whole thing down.
Measure twice, assemble once. Okay, let's move to the brain software side. This isn't just a dumb CCTV feed, right? This thing's doing edge computing.
This is where the HomeGenie server comes in. The camera sends data back to the server, and that's what runs the AI models like YOLO 8 or even V11.
YOLO as in you only look once, the standard for object detection.
Right, and it lets the system do pose estimation, scene understanding. It can tell the difference between, say, a cat and a cushion, or track movement.
But this brings us back to hardware. The docs were very, very specific about which camera board to use.
You have to use the ESP32S3 cam. The older, standard ESP32 cam just doesn't have the juice. The S3 has a dual-core processor and, more importantly, 8 millibeats of PSRAM.
And that's the high-speed memory you need to buffer the images for the AI to process.
Without that extra RAM, you can't run high resolutions or do any real-time analysis. The system would just choke.
So let's put it all together. You've got a dual-chip architecture splitting motion and vision, a capacitor-stabilized power system, and an AI brain that understands its environment. all talking over encrypted MQTT.
It's a surprisingly robust stack for a little DIY kit.
It really makes you think about where this is all going. We usually treat these as gadgets, but when you combine that autonomous navigation, the AI vision, with physical manipulation with the arm.
You're kind of crossing a line.
Right. I mean, are we looking at the prototype for affordable telepresence? Not just a screen on wheels, but a remote agent that can actually do chores in your house while you're at work?
It's certainly the first step on that road.
Something to chew on. Thanks for listening to this deep dive. Catch you next time.